Good morning to all of you. The topic for today is univariate forecasting. This is the data which we will use in today's session. So I collected the monthly data from September 2007 and data I collected up to June 2022. Here you can see that. So data is collected up to June 22 and rest of the time is for forecasting. So this time we keep for forecasting purpose. I want to forecast the value of Nifty till December 2030. So on this data set, we are going to work. So theory is less in today's session, practical is more. So you can see in this line, in this graph, there are red line, green line, blue line, black line. So all these are the forecasted values. This is the actual behavior of the series. And these are the forecasted values for the next 8 years. So how we can do the forecasting? So today we will learn. And you can see there are 4 types of forecasting. This is trend forecasting. And these 3 are curvilinear forecasting, exponential forecasting, and the ARIMA forecasting. So let's do one by one. So these are the broad topics that we will discuss in today's session. The first type of forecasting that I'm going to show you is trend forecasting. We have studied the trend in our previous session, how to analyze the trend. So when you run this regression model, YT is the time series, alpha is intercept, beta is the coefficient of the trend. This is simple time. ET is the error term. If we run this equation, the beta will tell you the trend. And if beta is found to be significant, it means there is a significant trend in the series. And then we can use this equation to further forecast. Similarly, in curvilinear trend, we use the term time square. Up to simple time, it is trend. And if we add the time square into the equation, this beta 2 will capture the curvilinear trend. If beta 2 is positive, it means upward sloping curve. And if beta 2 is negative, it means curve is moving down. So beta 2 will tell you what is the nature of the curve. In case of positive beta, the curve will come like this. In case of negative beta, the curve will move like this. And whether it is significant or not, it will tell you whether the curvilinear trend is significant or not. So we will do the curvilinear trend forecasting also. The third forecasting we will do is exponential growth forecasting. In exponential growth forecasting, we will take the log of y, alpha plus beta into time, everything is same as in trend equation. The only thing is that we apply the log of dependent variable. Log of dependent variable is known as semi-log model because we are taking the log for dependent variable and not log in right hand side. In this equation, beta will represent the growth rate. If your data is monthly data, then beta is representing the monthly growth rate. Multiplied by 12, it is annual growth rate. So beta is representing the growth rate. And this equation can be used for this kind of forecasting, exponential growth forecasting. So let me complete the 3 forecasting first, then we will move to the ARIMA. So I'm going to open this series in eViews. So I'm just copy this and I'm going to open this series from AnyViews. Just paste. Okay, file, open. So this is the series that we are going to use. And Nifty is the series. Software automatically consider this as a monthly data. You can see that 2007 month 9, 2010 month 10. So we are having the data from September 2007 and we are having the data up to June 2022. And rest of the series is for forecasting. So first we are going to do the trend forecasting. So Nifty is my dependent variable, time is my independent variable. Open as a equation. When you run this equation, we run the equation for the sample period of this. So period of sample you can see here, it is September 2007 to June 2022 because we are having the data up to June 2022. So this you have to consider. Now when you run OK, so this C is constant and 64, you can see 64. 64 is representing the trend. It means on an average, Nifty increases by 64 points every month in the last around 25 years. In the last 25 years, the Nifty on an average increases by 64 points every month. It is significant. R square is 85%. So now we want to do the forecasting. Just click on this forecast. You can see this option, forecast. Click on forecast. The new series name is trend forecasting. So I am giving the name to the new series trend forecasting and forecast sample. Now we are having this forecast sample. We are going to do the forecasting for July 2022 to December 2030 up to. So we are going to do the forecasting from July onwards. And we don't want actual values in the forecasting series. So these changes you have to do. The forecasting sample is for future. Don't click on this, uncheck this and click OK. Cross it. Okay. Now this is the trend forecasting. So let's see how the forecasted series looks like. So I am selecting the original value of Nifty, trend forecasting, open as a group. In forecasted series, up to 2006, there is no value. And these are the forecasted values. Let's plot the graph. So you can see that the red line is showing you the forecasted value of the series. So this line is showing you what is the average value of the Nifty in coming days, how the Nifty should move. And this drop is showing you there is a correction required in this series. Because in finance, there is a concept called irrational exuberance. Let me write the word. So what this irrational exuberance say that the market may move up in long term, it is fine, but it will move like this. So you must know what is the average value of the series and when there is a possibility of bounce back and when there is a possibility of drop down. So this can be also identified by this concept. So this is called trend forecasting. After trend forecasting, now I'm going to do curvilinear trend forecasting. So again, Nifty time, I'm opening as an equation and adding one more term, time square. So I am adding one more independent variable in this equation, and the sample is June 22, because we are having the data up to this period. And I added time square, a new variable for capturing the curvilinear trend. The R square is 92, which is more than R square of the trend equation. For the trend equation, it was 85%. It is 92%, so not a problem. And you can also see that time square is significant. The time square is found to be significant. So we will take this time square. It means curvilinear trend is much better as compared to simple trend. And we want to do the forecasting for Nifty using this equation. Again, go to forecast. Now, I am saving the new series in the name of forecasting, curvilinear forecasting. The sample should be from July 2022 up to December 2030. Uncheck this. Okay. Now, this is the way Nifty should move in the next 8 years. And we can see the graph separately also. Okay, let me minimize this. Okay. So if we want to see the curvilinear forecasting, select curve forecasting, select Nifty, and plot it. So you can see that this is the if Nifty, because Nifty have shown curvilinear movement in the past 25 years. So in future, if Nifty will continue its past behavior, this is the expected values of Nifty in the next 8 years. So approximately it will touch 35,000 in 2030. And this is more accurate as compared to simple trend forecasting, because we have seen that the R square of curvilinear forecasting is 92% as compared to the 85% in case of trend forecasting. So this is our simple forecasting, curvilinear forecasting. Now we are moving to the third case. Nifty time open as a group, open as a equation. Now I am taking the log. I am taking the log of Nifty. The sample period is, again, sample period means the period which you are using for making the model. And forecast sample means the sample where you are going to forecast. So this is our sample for the model. And it is again 89%, not very strong, because curvilinear trend is more accurate. With 92% R square, it is 89, but it is still better than the trend forecasting. After this, we can go to the growth rate is 0.007, 0.8%. So Nifty have a growth rate of monthly growth rate of 0.78%. It is approximately 8%. 7.8, if you round off, it is almost 8%, 0.8%. And 8.8 multiplied by 12, because it is a monthly growth rate. If you multiply it by the 12, you will get the annual growth rate. So 12 multiplied by 8, so approximately 9%, 9 or 10%. So this is the growth rate of Nifty in the past 25 years. And on the basis of this growth rate, we are going to forecast. So we believe that if the India keep this growth rate constant in future also, so what could be the value of Nifty in next 8 years? So we go to the forecast. The forecast sample is July 2022 up to December 2030. Uncheck this, and it is growth forecasting. So the series, the name of the new series, forecasted series, is growth. And okay. So let's see the picture in graph, Nifty and growth. So you can open both the series and make the graph. So you can see that if Nifty will keep the 9% growth rate or 0.78% growth rate monthly, the Nifty will move like this. So it is approximately, it will be 35,000 in the next 8 years. If the Nifty will continue its growth rate as in last 25 years. So these forecastings are very simple. And you know that if you just know how to keep the data, these 3 forecasting are very simple, just matter of 15 minutes. So we have done 3 forecasting. One is the trend forecasting, curvilinear forecasting, growth forecasting, and this is Nifty. So if I plot in total, so the 3 forecasting looks like this. And you can also write the, whenever you make this plot, you can also write that the R square is 85%, the 89%, and the red is 92%. So we are having more explanatory power in case of red. However, the end is same in both the cases. Both growth forecasting and curvilinear forecasting is representing this value, which is around 35,000. We are doing this exercise from the last 8 years. So 8 years back or 5 years back, we forecasted the value in 2022, and now we are going to do the forecasting in 22 for the next 8 years. When in 2016 I was teaching this in a class, and at that time Nifty was at around 10,000, and when I show them that Nifty will reach 18,000 in 2022, so nobody can believe it. But now this kind of trend forecasting and the curvilinear forecasting will tell you that how the series will move in the next time period. Is your choice. You can calculate, you can forecast for 20 years, 30 years, 40 years, as per your choice. Okay. So basically, the average for this value is the average value that Nifty should have in next 8 years. So there are different time periods of the forecasting. If you are doing the forecasting for the next year, it is called static forecasting. If you do the forecasting for the long period of time, it is called dynamic forecasting. So after learning these 3 basic type of forecasting, now we are moving to the complicated forecasting, that is called ARIMA forecasting. So you have to now be attentive to understand the concept. Now first of all, I will explain you the basic concept of ARIMA, and then we will move to the practice session. So time series forecasting, and it's still univariate, can also be done on the basis of 2 concepts. One is called past momentum. You may heard about the momentum trading, momentum in the series. And if any series is having some momentum, also known as inertia, in science we call it inertia. If some series is having some inertia, momentum, this information can be used to forecast. And this concept is called autoregressive. Autoregressive means the past behavior is important to forecast its future value. So on the basis of the momentum, we make this series, this equation, that YT can be forecasted on the basis of its previous value. So YT minus 1 is the lag 1 value of Y. Lag 1 means 1 day before or 1 month before. YT minus 2 is 2 time period before. P time period before. So you have to consider the past values of Y to forecast the next value. Because we are running a regression model, dependent variable is today and the past behavior is the independent variable. So this series is called autoregressive. So we are having many autoregressive series like Garch. So in this case, we are taking the past volatility in the equation. In second case, we are analyzing the sentiment of the mood. So let me explain the concept of sentiment. That is something new. And this concept is quite important. Suppose the value of today is 100. So assume any financial asset. And today, the value of this financial asset is 100. And we are expecting it 100, let's say 2. It is the expected value of the asset. Now it will move to the 90 also, it will move to the 110 also. If negative information will come, the price will decrease. If positive information will come, the price will increase. So we are having two cases, case 1 and case 2. In case 1, the error will be equal to actual value minus predicted value, which is 90 minus 102. In second case, error will be 110 minus 102. So in first case, error is negative. In second case, error is positive. So as I already told you that the error term is having two cases. One is the sign and one is the size. The minus is representing that there is some strong negative information in the market. There is some strong negative news in the market, because of which the market is down. And 12 means how much the market is reacting to the negative news. Minus 12, because it is quite higher. So it means the magnitude of negative information is very high. So this is the meaning of error term. So in a whole time series equation, the error is representing the shock. The error is known as shock. Shock means something unexpected. So some unexpected news comes as a result of which the market respond to it positively or negatively. Now the question is that, do you think the shock will absorb in only one day? So we assume that this YT is influenced by this shock. The ET minus 1 is the shock on the previous day, whatever news comes. So previous day, error of the previous day. So do you think the error of the previous day will also influence YT? Answer is yes. Why? Because in human being, it is a nature that some human beings are react quickly, right? And some human beings are very slow. They give the reaction but slowly. So suppose this is the population. This population react on the same day. There must be some population which react after 2 days, and there must be some population which react after 3 days. So a reaction comes in sequence, and this is because of this is called irrational, and one is information asymmetry. There is a term called information asymmetry. What is the meaning of information asymmetry? There are two meanings of information asymmetry. Number one, everybody is not having the same information at every point of time. Some investors are well informed. Some investors are not informed. They will get the information after some time. So because of this information asymmetry, some investors which are well informed, they react quickly, and some investors which will get the information delay and late, they will respond after 2 days, 3 days, 4 days. So we believe that the response from the investors comes in sequence. So that's why we make this equation, that's yt is equal to et beta 2, this is et minus 1, this is et minus 2 plus beta 3 et minus 3. So the error term of yesterday also influences the next moment. The error term maybe which comes 2 days back, which also influences the today movement. Similarly, the error term which comes 3 days before or 3 months before is also influencing the movement. And it's all because of information asymmetry. And the second meaning of asymmetry is that some investors are proactive, some investors are passive investors, so they react very late. So that's why, because of the different concept, different results of information asymmetry, the error term will have a impact for many days. This is the concept of, this concept is known as moving average. This concept is also known as moving average. And this concept is very, very important in time series, because once there is a large crash in the market, it will continue for more time, some more time. When there is a huge jump in the market, it will continue for some time. And especially in case of crashes, crashes will continue for some time. So whenever there is a crash comes in the market, it will continue for some time, because it is a feature of negative information to have more contagion effect as compared to positive news. So this concept we will use in case of moving average. So we are having two cases which we incorporate in ARIMA model, is incorporating the past information of the series and the past error term of the equation. So this concept is called AR concept. This concept is called MA concept, moving average. And if you combine both the terms, it is called ARMA, ARMA. AR is for auto-regressive, MA stands for moving average. And when we combine these two terms, it is called ARMA term. Or I, we then add it. I means stationary series. We want I equal to 0. So when I equal to 0, the model is called ARIMA forecasting model. Before moving to the model, I am going to explain AR-MA series first. So what are the features of AR series, MA series? So let me take a very simple example. There are two types of people around you. You can observe this. Some people are very moody kind of people. So some person are very moody. They changes their behavior very quickly, right? So sometimes they are very sad. Sometimes they are very happy. So their behavior changes very soon. So these are called moody people. And some people are stable people. So almost every time they keep their behavior similar. So similarly, there are two types of time series. Some time series changes very fast, like stock market, and some time series don't change frequently. They changes very less, like gold price, uh, inflation rate, interest rate, GDP, IIP. There is not much crashes in this. So they move steadily. When they're moving down, they move down for some time. When they move up, they move up for some time. Not zigzag motion. So first of all, we have to analyze what is the nature of the series, whether it is a stable series or whether it is a moody series. Moody series means anytime up, anytime down. A stable series means when it is moving up, it will move up for some time, and when it is moving down, it is moving down for some time. So autoregressive concept is more meaningful with a stable series. So when you think the series is stable, a stable kind of series, it means autoregressive component is a major component in the series. Similarly, in autoregressive series, which is a stationary, which is a momentum series, inertia series, stable series, you can call it with any name. The YT can be predicted on the basis of their previous behavior. If you know that yesterday the person was sad, so the possibility is very high that today he is also sad. So YT depends upon the previous behavior of the series. So this is called autoregressive process. On the other side, we are having the moving average. YT depends upon the error term of previous day, error term of 2 days back, like this. This is MA model. Now, before moving to the ANIMA model, I just want to show you how the nature of the series. So it is a quite complicated simulation, but if you understand this simulation, you will understand those concepts which cannot be explained by any book. So now I am showing you this simulation. For saving my time, I already make this file, but let me explain how we are simulating the series. This is a white noise. White noise, you know that a series which is having the zero mean, constant variance, random behavior. So random series with zero mean and one standard deviation is a white noise. The definition of white noise is any stationary series with zero mean and constant variance is white noise. So we develop the white noise by this function. Random walk, you know that the equation of random walk is yt plus et. So lag 1 means yt minus 1 plus white noise. Random walk with drift. So we use these series for simulation of AR1, AR2, AR3, MA1, MA2, MA3. So now I am going to show you this series. Similarly, if you see this MA2, like for example, so white noise plus white noise of the white noise we are considering as the error terms. You know that the error terms are white noise always. So 0.4 into white noise of the yesterday. Lag 1 means yesterday. Lag 2 means day before yesterday. So we assume that some information is coming from the lag 1 and some information is coming from lag 2. Similarly, when we are simulating the MA3 series, so it is white noise coming from lag 1, lag 2, lag 3. Okay. Just I am showing you the simulation once again. This is my, let me open a new file. Because this concept will be helpful in many other models. So that's why I'm incorporating this white noise. So how to develop the white noise? So I am applying a function norm inverse, it will give me the values, the x values with random function, mean 0 and constant variance 1. The standard deviation is 1. So after this you will get the z scores, which comes in between +3 and -3. So let me generate for 500, approximately 500 values. So it is a white noise, the completely random error term. So this is the best way to report a white noise, and taking the 3 decimal point. Okay. Now I'm showing you the random walk. So the equation of random walk is, you have seen earlier that random walk yt is equal to yt minus 1 plus et. So this is the equation of the random walk. Okay, let's say the any day value is 1. Now yt minus 1 is 1 plus et. Et is the error term. So white noise is the proxy of the error term. So I am taking error term as white noise. So you can assume any value of today, let's say 5 rupees, and just plot it. So your random walk will come. So let's see how it look like. So you can see that this is a movement, random term movement. If you press F9, you can generate the different simulations of our random walk. So these are the different possible movements of a random walk. So I hope random walk is clear. Okay, now I'm going to show you the other series, random walk with drift with small momentum. So let's say the price value is 5, and I'm just adding a momentum of 0.05 equal to. So what is the equation? Let me write the equation first. Random walk with drift is equal to alpha plus yt minus 1 plus et. This is the equation of random walk with drift. So let's say drift is 0.05. This is the drift plus previous value is this, plus the error term is this. So this is my equation, random walk with drift, and let's plot it. So you can see that there is a possibility of upside movement, and if we, so most of the time this series is moving upside because we give very small drift, so that's why small movement you can see. And if I give large drift like 0.1, so you can see the upside movement is quite high. So you can see that now this series is moving towards upside most of the time. This is the impact of drift. Now the next series I am going to show you, AR1 series, AR2 series, AR3 series. So similarly we can go for AR4, AR5 and so on. But what is the meaning of this AR? So I'm writing the equation, AR1, AR2 and AR3. So AR1 equal to the yt minus 1 multiplied by 0.8. Because we are not considering the unit root, we are considering the beta is equal to 8 plus ET. So this is AR1 series. Similarly, YT minus 1 multiplied by 0.4 plus YT minus 2 multiplied by 0.3 plus ET. This is AR2. This series is giving 40% information. Second lag is giving 30% information. We are giving more weight to the latest value. Similarly, we can write AR3 YT minus 1 multiplied by 0.3 YT minus 2 multiplied by 0.25 plus YT minus 3 multiplied by 0.15 plus ET. So now I'm going to generate, because this is a pure simulation, and the advantage of simulation is to understand the basics. So now I'm going to simulate the series. So starting value is I'm taking 5. Okay. Now this value is equal to 0.5, 5 rupees, YT minus 1 multiplied by 0.8 and plus white noise. This is AR1 series. The information is only coming from the 1 lag. Okay, now in this case, I am taking the AR2 series. The first one is just like AR1 multiplied by 0.8 plus ET. But in second case, I am running the two values. This is YT minus 1 multiplied by 0.4 plus, because it is AR2, so we are taking 2 lag. This is second lag multiplied by 0.3 and plus ET. This is AR2 series. Similarly, we can go for AR3. Now here I'm not going to AR3, I'm going to MA1, because I expect you that you understand this concept. Now, how to generate MA1? MA1 means the error term. The series is affected by the error term, equal to today error term plus 0.8 multiplied by previous error term. So if you want to see the equation, this is equation is 0.8 multiplied by ET minus 1 plus ET. This is MA1. Similarly, I will develop MA2, 0.4 into ET minus 1, 0.3 into ET minus 2 plus ET. So we can generate MA1 and MA2 series. This is MA2 series. So we will generate from here. This is ET minus 1 multiplied by 0.4 plus ET minus 2, 2 days back, multiplied by 0.3 and plus 2 days error term. So this is called MA2 series. So in this way, we can simulate the AR1 and MA1 series. Now I'm closing this, not saving it. I already saved it into another name. So I already created this file AR/MA simulations, which I give you. You can see the formulas from here. Now what I'm doing, I'm going to open this series in eViews and want to show you something. So I'm going to open this, the simulated file. Okay, so you can see that we are having AR1, AR2, AR3, MA1, MA2, MA3. So now what you need to do, you need to plot each series. Like for example, AR1, how this series looks like. So this is the kind of AR1 series. And if you plot the parallelogram of it. Okay, now I'm going to show you something which is very, very important. So we are having a graph, this is called AR correlogram. This is called autocorrelation and partial correlation. So what is the meaning of autocorrelation and partial autocorrelation? Let me explain. And ARIMA cannot be understood. We cannot understand the ARIMA without understanding this concept. So just give me some attention. Okay, so I'm going to explain you this result. Suppose you are having a series yt minus 1, yt minus 2, yt minus 3, and so on. Now I am writing this series from yt minus 1. Okay, so if you calculate the correlation between original series and lag 1 series, this is lag 1 series, this is lag 2 series. The correlation, this correlation is representing this correlation between this and this. This second correlation is representing the correlation between this and this. So correlation between yt and yt minus 1 is correlation at lag 1. Correlation between yt and yt minus 2, it's correlation at lag 2, and so on. So if you see this series, the only one spike is found to be significant in partial correlation. Now, what is partial correlation? Partial correlation is the correlation between yt and any lag after controlling the intermediate lags. Let's say if yt is correlated with yt minus 1, yt minus 1 is also correlated with yt minus 2. Yt minus 2 is also correlated with yt minus 3. So this is a chain. Now, if I want to see correlation between yt and yt minus 2, you need to remove the effect of this. If you remove the effect of this intermediate, this is called partial correlation. Partial correlation means after removing the effect of intermediate series, whatever is the correlation left is called partial correlation. And the correlation between yt and yt minus 2 without removing it is autocorrelation. After removing, partial autocorrelation. So I hope you understand the concept. Now see carefully, how many spikes are significant in AR1? Only one. If I click on AR2 series, now tell me how many spikes are significant. So you can tell me how many spikes are significant. 2. So when 2 spikes are significant, it means the series is AR2 series. Similarly, if I click on AR3, and I'm plotting the correlogram, now tell me how many spikes are significant in the partial correlation. 3. So the answer is that if you have any series and there are 3 spikes significant, it means this is AR3 series. If 2 spikes are significant, it means there are 2 series. If only 1 spike is significant in partial correlation, it is AR1. So how many AR? The question is that how many AR terms we will include in the ARIMA forecasting. So answer you will get from the correlogram. Okay. So in correlogram, in partial correlation, so my conclusion is that if I see the partial correlation, if only 1 spike is there, it is AR1. If 2 spikes are significant, this is AR2. If 3 spikes is significant, it is AR3. If 4 spikes are significant, then AR4. So how many spikes are significant here in partial correlation will tell you that how many AR terms you have to include in the ARIMA forecasting. Now let's move to the MA. It is MA series. And let's move to the correlogram. Now you can see that this partial correlation is not meaningful for me. This part is important. Autocorrelation, only 1 spike. So how many MA terms we have to include, how many error terms we have to include will be decided on the basis of autocorrelation. So only one spike is telling you this is MA1 series. Okay, now let's move to the MA2 parallelogram. Now how many series are significant here? So this series is MA2 AR1 basically, but only two terms of MA and one term of AR, MA2 AR1. So in this way, we decide that how many MA and AR terms we have to include. So let me go one more MA3 parallelogram. So you can see that there are three series significant in this. So how many MA terms we have to include? 3. So this autocorrelation will tell you that how many error terms we have to include in the model. Partial autocorrelation will tell you how many AR terms we have to include in the model. So like this, we decide AR terms and MA terms. So ARIMA forecasting is also represented by the term called PDQ. PDQ. P means how many AR terms you are going to include in the series. D means it is always 0. It is assumed to be 0 because D means no differencing should be required to make it stationary. If you are going to ARIMA forecasting, D must be 0 means stationary must be stationary. And how many AR terms you are going to include is P. How many MA terms you are going to include is MA. AR is decided by partial correlation and MA is decided by autocorrelation. Autocorrelation. This important thing you need to remember. So how many P DQ, how many P and how many Q we have to incorporate in ARIMA is decided by correlogram. So this is very, very important to explain the ARIMA forecasting. So assuming that you understood the concept of AR and MA, AR means the momentum and MA means the error term, impact of the news. Now we are going to combining them. So let's go back to the PPT. So I simulated all the terms, AR1 series, AR2 series, MA1 to MA1, MA2. These are the idealistic series, and they are having very clear partial correlation and the autocorrelation. But in practical, we never have these clear terms. We are having the mixed series. So we have to analyze all the things like AR process have autocorrelation is dying, and number of non-zero point means how many spikes are significant is AR order. How many spikes are significant in autocorrelation? It means MA order. And if both are significant, then it is called ARMA process. Ideal conditions I have shown you, but in practical we are having the mixed series, so we have to count how many AR values are significant, how many MA values are significant. So after that we will discuss we will design the ARIMA model. So ARIMA model looks like this. P and Q. P and Q means the number of AR terms. Number of AR terms means number of past terms. And Q means number of error terms. So how many past terms, how many error terms we are including is known as ARMA process. So like in this case, we are YT minus 1, YT minus 2, YT minus P, UT minus 1, UT minus 2. These are the error terms. So ARIMA forecasting model can be written by this. Okay. So this is ARIMA. Now, how we proceed in ARIMA forecasting? First of all, we have to identify that how many AR terms should be included, how many MA terms should be included. Then we go to the model, then we do some diagnostic testing, and then we are going to forecasting. So this is the simple process of ARIMA. The identification term is basically the how many AR and MA terms we are going to include. This is called identification. Then estimation, we will run the estimation model. In model testing, we will do some testing whether the model is good or not. We analyze the residuals of the forecasting model. Because if the forecasting model is good, the error term should not have any information. So we have to check whether the residual is a white noise or not. Error term should be a white noise. Then we are having some information criteria like AIC, BIC. These values should be minimum values among all the models. So I will show you how to do all these things. Now, if I ask you, if you have this kind of model, so can you tell me that which is this series? AR term is autocorrelation is declining. Only one significant spike here. So it is a pure AR term. Similarly, if you see this series, so this series is basically, okay, it is moving. Number one. So this is AR2 series. Two significant spike in partial correlation, and autocorrelation is just declining. So it is a pure AR2 series. Now, if you see this series, it is pure MA1 series. Only one spike in autocorrelation, and partial autocorrelation is declining. This series is again MA1 series. Partial correlation is having many significant, but only one significant in autocorrelation. So it is a pure AR1 series, MA1 series. This series is MA2 series. Only two spikes are significant in MA. So in this case, both series are moving down. So it is ARMA series. So there are different possibilities we have to see. Now, in all these possibilities, we have to find out that which kind of series it is, how many AR terms, how many MA terms we have to consider. So this we have to find out. Okay. Now then we have run the model. The rest of the things I will show you in eViews. So this is our Nifty. So first of all, we have to check whether the Nifty is a unit root series or not. So whenever you do ARIMA, first of all, you have to ensure that the series is stationary. I know that this is not stationary, so I have to check whether the series is stationary after taking the D-log or not. So I am generating this series. Nifty return equal to D-log of Nifty. So I'm just trying to take the D-log, and sample I can take only up to 22.06 because after that we don't have the values. So we have now Nifty return and confirming that whether it is stationary or not now. And now it is stationary. So you can see that after taking the D-log, the series becomes stationary. Fine. Then go to the correlogram. So in correlogram, the series is coming very different. The ideal series comes very clear, and the practical series comes very different. So only fourth spike is found to be significant, nothing else. So it is an indication that you can take go to up to fourth level. So now I'm going to make the model. Some hit and try we have to do here also. So D-log Nifty. So I am taking AR1 and MA1. So first let's start with this. Sample model I am making up to 22.06 and okay. So you can see that both AR MA terms are significant, but I have to add constant also. Constant must come. So both AR term and MA term are found to be significant. So it means we can take it. And one thing you have to note down, this AIC value is minus 2.6745. If this value come down, then it's always better. Now I'm going to the estimate. Whenever you want to go back, you go to click on the estimate. So I am adding one more thing, AR2 and MA2. And this is minus 2.674. 2.76, it is decreasing, so it is good. And MA2 is also significant. And then AR2 is also significant. So there are many permutation and combination that we have to try. And they may be insignificant because of the multicollinearity issue, because in ARIMA multicollinearity is very common, so we cannot ignore that. The only thing is that the forecasting accuracy will improve. Here R square is 12%, earlier it was only 3%, so this model may be better than previous. And one more thing, whenever you run any model, let's say I started with MA2, AR1, MA1. I have to see one more thing, that how the error term of it is looking. So I am developing the residual. This is the residual of model 1. And I will plot the corogram of the residual. So still you can see that the information is still there. In error term, this information is not captured. So the model is not good. So it means the model should be modified. MA2. So we have to try different models. MA2 also. And I know that R square increases, but I have to check still. Make residual series. This is for residual of ARMA 22. And make the corogram of it. So you can see that still the information is not captured. So I have to take 4 also. So I'm improving the model by adding AR3, AR4, because up to 4 the information is significant. Similarly, I can go to MA3, MA4. So now I'm modifying the model and we'll check the this value, the R square and AIC. Now it is minus 2.75. So it is decreasing. Now it is minus 2.83. It is 20%. So we can say this model is much better as compared to previous one. And I have to check the residual series of it. This is residue of ARMA 44. And let's check the corogram. So now you can see that we captured all the information. All these spikes are less than the dotted lines. So almost for up to 10 lakhs, you can see all these spikes are within the range. So it means this model seems to be better. And second thing which you need to check is the unit to test of the error term. It must be stationary. Then you have to check the normality. Yeah, seems to be normal. Some outliers are there. Mean is almost 0. Fine. So this is the diagnostic testing. Diagnostic testing means whether the error terms are having any information left or not. So we have seen in the corollagram that there is no information left. So now we can see that this model is better. So we can go to the forecast. After analyzing all these things, and AIC is also least minus 2.883. It is minus, so if it increases, it means it is decreasing. Negative side. So I will try one more thing. Whether by adding AR5 and MA5, is there any significant change in AIC or R square or not? So it is 23 and 20 to 23%, but slightly it is coming down. Earlier it was 2.83, now it is 2.84. So slight change is there. So there are so many permutation and combination we can do here. Now after that, once you make your model, when you combine your model, suppose we finalize this model, we can try to 6, 7, 8, 9 as it is not a problem, but somewhere you have to stop. So after doing this, highest R square 23%, this is lowest, and then we can go to the forecast. The Nifty forecast is now I'm giving a new name, ARIMA forecasting. So I am doing the ARIMA forecasting. The forecasting sample must be in the future. 22, 6. Dynamic forecast. A static forecast give you the next period value only. Dynamic forecast give you the long-term value. We don't want actual information in the series. And so I think that's it. So we using this forecasting sample, doing the ARIMA forecasting. Okay. And now I want to show you the forecasted values. So we are having the ARIMA forecasting now. This is ARIMA forecasting. This is Nifty. And we can go for open as a group. Let's make the graph. So this is the value. This is the possible values of Nifty in the next 8 years. So according to the ARIMA forecasting, it will cross 35,000. It will cross 35,000 in the value after 8 years. So you can report this forecasted value by the graph. So red line is the actual behavior, and blue line is representing you the forecasted behavior. So you can represent the forecasted behavior like this. And after this, you can combine all the forecasting, ARIMA forecasting, curve forecasting, growth forecasting, trend forecasting, and Nifty. So now I'm combining all the forecasting values. So these are the different forecasting values. So ARIMA forecasting is telling you this value. It is approximately 37,169. And the least value is, minimum value is 21,000 approximately. So 3 model says the forecasting value is around 35,000. And trend value is the least important model here. So these are the different type of forecasting models we can apply on any of the series. So in my example, I took the monthly data. You can take the in daily data, because volatility is very high, so forecasting may not be very accurate in case of daily data because of high volatility. So the purpose of forecasting is to get an average value, average possible value in the future. So what could be the average value in the future? ARIMA forecasting is found to very accurate in case of demand forecasting, sales forecasting, so economic forecasting. ARIMA forecasting is highly useful and applicable in the industry, and they are trying to predict the future value in the same way which I am going to tell you, which I explained. So this is the ARIMA forecasting. And if you want to forecast for the next month, you can do simple static forecasting. Okay, so where is our equation? Yeah, so we are having this equation. And suppose you are interested in only next value. So you have to go for, only thing is that you need to change the forecasting sample. The forecasting sample is July. And let's say August. So I want to forecast for the only next 2 period. And it is static forecasting. Static forecasting. So forecasting sample you need to define as your sample period. I am doing only 1 period forecast. So the forecasted value in the July is this. And you can see in the ARIMA static forecasting, it will give you only single value for the next month. In July, the Nifty can touch 16,413. So this is the next month forecasted value for the Nifty. The average value of Nifty, which should be there. So you can do the 1 period forecast and dynamic forecast with the help of ARIMA forecasting. And after that, we should know some. Okay, so this I've already cleared. There are some extensions of ARIMA. The analysts are using different softwares for these extensions, like Animax model, Verimax model. So there are some other the modified forms of ARIMA, but only thing is that you must have some X values to forecast. You must have some independent variables to add into the ARIMA forecasting to edit. For example, I'm just showing you one example of Arimax. Let me close this equation. Yeah. Suppose I have this equation and I want to forecast for the next value of, let's say, gold. So which kind of equation I will make? Let's see. So it is a daily data. So we are having the data up to 29 March 2019 from this. So go to quick estimate equation. So first of all, you have to create some ARIMA model. And let's say take 2 values. And then you can take the D log Nifty or D log USD INR. If you use this equation, but this equation can be used for only static forecasting, not the dynamic forecasting. Only 1 period forecast you can do. So we are having the data up to 29th March. This is the forecasting equation. All the year and MA are significant. So when you do forecasting, only thing is that you have to increase only 1 day, 30. And this is 33. So because I'm doing only next day forecasting, static forecast, gold. So Arimax model is only used for 1 day next forecasting. the software say that you have to increase the observation. So let me do that. Go to proc, structure resize. So end date is now. Let me explain by undated. So we have 4046 observations. Now I'm adding 404, one more observation. So I'm adding one more observations. Continue. Forecast. Okay, now the software will not take the dates. So 1, 2, 4, 0, 4, 6 observations. 4047. Now I will forecast for 4047 next period. Static forecast and okay. Okay, some problem is coming. Software saying some missing data. Okay, so in this way, you can see the forecasted value of gold for the next day is this. The forecasted value you can see in the last. So the last value is showing you the forecasted value. In this way, you can do the forecasted with the help of some independent variables. So I hope you learned ARIMA forecasting today. And if anything is left, so we can discuss in the discussion.